Hi guys, so in this video I will be doing network in graph theory. So I will be covering about simple graph, non-simple graph, weighted graph, unweighted graph, as well as subgraph and tree. So stay tuned.
Graph is basically made of vertices and edges. So let's look at the graph on the right. This here is a graph represent the vertices, which is V1, V2, V3, V4, V5 and V6, and edges, which is E1, E2, E3, E4, E5 and E6. So we have 6 edges and 6 vertices. Edges connect vertices, so that's why it is also called links or relation. Vertices also known as node. So as long as there is one vertex, it can be considered graph. That means there can be just one vertex without any edges. There is no minimum number of edges. However, there needs to be at least one vertex. So let's look at how to represent the vertices and edges. So it represents in set notation V equal to the name of the vertices. So for example, in this graph, V equal to V1, V2, V3, V4, V5 and V6. So the number of vertices equal to 6. Edges equal to E1, E2, E3, E4, E5 and E6. And number of edges equal to 6. Degree of vertex. The number of edges that connects the vertex to other vertices. Degree of vertex 1 equal to 1, which is just one edges that connects the vertex. So degree of vertex 2 equal to 3, which is E1, E2 and E3. Degree of vertex 3 equal to 3, which is E2, E4 and E5. Degree of vertex 4 equal to 1, which is just one edges that connect the vertex. So it is E3. So degree of vertex 5 equal to 2, which is E4 and E6. And degree of vertex 6 also equal to 2, which is E5 and E6. So to calculate the degree of vertex, we have two methods. First, we must do list and calculate the total of degree of vertex. Or second, we can use the formula. So the formula is degree of vertex equal to 2 times number of edges. So from this graph, it has 6 edges, so 6 times 2 equal to 12. So that's how to calculate the degree of vertex. Multiple edges. What is multiple edges? More than one edge connects two vertices. For example, E7 and E4 are connected to V3 and V5, which is this E7 and E4 connected to V3 and V5. Other example, E6, E8 and E9 are connected to V5 and V6, which is this E6, E8 and E9 are connected to V5 and V6. So the number of vertices equal to 6 for this graph and number of edges equal to 9. So the degree of vertex, we use the formula that we learned, that degree of vertex equal to number of edges times 2. So for this graph, the number of edges is 9. So 9 times 2. So the answer is 18. Loops. What is loops? An edge that connects a vertex to itself. Like this graph. For example, E7 that connects a vertex to itself, and E8. Simple graph. Graph without multiple edges or loops. So we can see from this graph, if the graph doesn't have multiple edges or loops, it is called simple graph, okay? So remember. Non-simple graph. Graph with multiple edges or loops or both. So first graph, it has multiple edges. So second graph has loops, and graph 3 have both. Weighted graph. Edges are assigned values or weight. It means like the graph has values. Like this, A to B is 5, B to D is 3, C to B is 7, C to E is 2, C to F is 1, and E to F is 9. So like that. So unweighted graph, edges are not assigned values or weight. So it is called unweighted graph. Subgraph. Part of the graph redrawn, whole graph redrawn, edges and vertices at the exact same position. The example. Question 1. Justify whether the graph is subgraph or not. So from this graph, we see that it same like this graph, so it is a subgraph. Question 2. Okay, we see A, B, C, D, E, F. Okay, same. 4, E4, E2, and E3, and same. So it is a subgraph. Third question. Okay, we see A, C. So we see that this graph show C, but the original graph show B, so it is not a subgraph because this B and C. Okay, so it is not a subgraph. Okay. Last question. A, B, C, D, E, F. A, B, C, D, E, F. So it is a subgraph. 3. A simple graph that doesn't have no multiple edges and no loops. All vertices are connected and number of edges equal to number of vertices minus 1, and the tree graph must be acyclic. It means like each edges connected to other vertices. Okay, so if the graph doesn't connected, so it is not a tree.
Okay, so how my video, I know my English is bad, but yeah, I try. So hopefully that you guys can get many knowledge, new knowledge from this video, and I hope that I can help you in your exam. Okay, bye.